Good afternoon, ladies and Robert. Good to have everybody here today. I want to tell you where we're headed the next few days. What we're going to do today is probably we're going to finish our work on trigonometric identities today with this paper we're doing. And then we're going to be having I'm going to give you a test preview that we can look at tomorrow and that you can kind of look at on your own. And then on Wednesday we would have a test on mainly chapter 4 of trigonometry. And then after that we're going to be doing a lot more work on SAT preparation, kind of going into the break. So that's sort of what our plans are for the next couple weeks. So basically on these right here, what we're looking at is use basic identities to simplify the expression. And the main identities to be used on these things are going to be what we call the quotient identities, which are going to be these ones here. Tangent theta equals sine theta over cosine theta. We have cotangent theta is equal to the reciprocal cosine theta over sine theta. Then on your ACP formula chart, we have all the reciprocal identities, and the primary ones of which would be like cosecant theta is going to be 1 over sine theta. Secant theta equals 1 over cosine theta. Cotangent theta equals 1 over tangent theta. We also introduced last week the Pythagorean identities, so we're going to be using some of those too. So we're going to kind of compile these together here. And basically, the main strategy on these is to turn these things, if you see like in this case here, tangent x, use the reciprocal identity there and turn things into sine and cosine, and then simplify from there for the most part. And so if that's the case here, what will we do on this first problem? What would be a first step? And what you're doing with these most of the time is you're expanding them out to make them bigger before condensing them. And so you have to go on some kind of a faith or some kind of a thing that you're going to get someplace. And I can promise you, as an experienced worker of these level of problems, is it's a lot of times not always readily apparent which will get you someplace. So that's one of the challenging things about this section. What are you going to do first with that tangent x to expand from your identities here? Yeah, and so we do that, and it was exactly right. So we're going to rewrite this tan x as sine x over cosine x. Now one thing you have to be ready for is that you could have different letters, like the identity itself will have theta usually, but here you have x, and now we rewrite cosine x here, and then we go ahead and how does this simplify? So these will simplify here, and you're left with sine x as your answer. Okay, and then you can test using your calculator for equivalency to test the values to see if that's right. So for instance, if I want to test this, I could get to my calculator and I could leave it in radians here. I could put 2 storage x, and I can just, I know I'm in radians, I can put tan x cosine x, so tan x cosine x, and we get this, and we see if we get the same as sine x. I hope we do. Sine x should get the same thing if that's right. It's right, okay? So you can just try to experiment test if you want to see if they're right. Okay? Let's go on to the next problem here. Okay. What I'm going to do is I'm going to call on somebody to help me with this one. I have a list of students here. I think Justin is still on the list, but Robert, you're so what would be your strategy on this one, Robert, you think?
I don't know, because tangent can be expanded down as sine x over cosine x.
So tangent, yeah, so you're saying replace this with sine x over cosine x, okay. Then what else?
And then the cotangent, that one would expand it, that one would be cosine x over sine x. And we'll all cross out.
So this will cancel this, and this will cancel this. What are you left with?
Nothing, just
1. Okay, whenever you say cancel out and the answer is not 0, don't say nothing. Say 1. Thank you, okay? So you see how this works out? You expand it out and just collapses down to nothing. And they'll usually collapse down to something similar or simpler than what it is, but let's see here. Hey, thank you, Robert. Good job.
I already knew it.
Okay. Let's go on to the next problem here. Okay, we get to problem 12. So I want to call on somebody for this one too. Help with this one. Looks like Jana. Okay, Jana, we got you for this one. What do you think? Okay, so you got cosine u over sine u, okay.
Yeah, and then sine u and sine u can cancel each other out, so you get cosine u.
So that cancels out, so you get cosine u, is that right?
Right.
Okay, does that look right? Everyone get that? Okay, good. Good work. That was like a mosquito landing before it tripped on Riley's bag. Okay. Okay, what about this one here? Does that look pretty ugly?
Yes.
Okay, I want to show you something here you can do with this one. Remember we had this one here, sine squared theta plus cosine squared theta is equal to 1. Remember that? What happened when we divided by sine squared theta? Or, excuse me, by cosine squared theta? So you divide by cosine squared theta. Equals secant, that's 1 over cosine squared theta, yeah. So what you get is you get tan theta squared theta plus 1 equals secant squared theta. You think that's helpful to you? Should be. Does that look like it's helpful?
A little.
You see what you can do? You can take this and replace it with this. Ever thought about doing something crazy like that? So here you work this out. I'm just going to go ahead and work. So you get secant squared theta replacing this over cosecant squared theta. And what do you do with these guys? What is secant? 1 over cosine, right? And what is cosecant? 1 over sine, right?
Yeah.
So what do you do with this guy here? Yeah, what you do is you're dividing by a fraction so you can multiply by its reciprocal, right? So what do you have left here? Oops, well, it's over 1. It should be over 1. Excuse me. So what do you have left here?
Cosine theta times sine theta.
Nope.
Wait, no, it's sine squared theta versus cosine squared theta.
Which is going to be what? What does this simplify to here? Tangent squared theta. So this is going to be your simplification of that. Okay? Again, pattern is look for simplification, expand out, and then collapse, and hope and pray that you come to something simpler, which it may or may not be. And then if that doesn't work out, what do? Try something else. We haven't seen exactly try something else yet, but that'll happen sometimes. Okay? Okay. Let me see these last 2 here. Okay, yeah. Should be able to do this one. Okay, do you have an idea on this one? I'll give you a hint, okay? Sine squared theta plus cosine squared theta is equal to 1. I will choose somebody in half a minute here.
You guys know, no, it looks like you have to subtract and divide.
Okay, let's go see what we got here. We got one of these young ladies here, ready, willing, and maybe able to help. Well, any ideas, Riley, on this?
I take a guess.
What'd you get? What'd you guess? What'd you do?
Does it, do you put them all over cosine squared theta?
Well, here, let's see if we can rewrite this.
Over.
If we can rewrite this. Can we rewrite this?
Yes.
How can we rewrite this? How can we rewrite this?
Sine squared theta?
Yeah, so what we have sine squared theta
Because you subtract.
is equal to 1 minus cosine squared theta.
Okay, I'll figure
So now you see what we're doing here?
Yes.
So now we got sine squared theta over sine theta, which is going to be,
Or I was writing it down. Sine squared theta over sine theta
is going to be
is going to be
sine
sine
theta.
theta.
So that is our answer. Okay, so a little bit of manipulation here, right? Try to figure out what's going on. Okay. Let's go on here to 15. Okay, 15. This one here could be a little bit tricky, maybe, kind of, sort of. But let's see what we got here. Elizabeth, okay, Elizabeth. Yeah, this one here is a little weird, but it's going. What, you have any idea about what's going on here?
First thing I want to say is negative cosine squared x, just because, logically, that's what my brain thinks.
Yeah, I mean, that's really probably a good way to go. So let's go ahead and take a common factor out of here. Cosine x, and we'll have 1 minus cosine squared x, right? Okay? And so what can you do with this thing now? Look at number 14. What can you do with this thing here? What is this the same as? Yeah, so this is going to be the same as sine squared theta. And so, so what this is really, you've reduced everything in terms of sine and cosine, and so I don't see anything you can do to make things simpler than that. Okay? So we'll call that a good exercise there.
Number 16.
Yeah, so number 16, we got a few things going on, number 16. Yeah, one of these sawed off stars here. All right. 16. Does that look pretty ugly?
Yes.
It's really ugly, but I know it's pretty. I know there's a pearl in that oyster there, someplace. Pretty. Okay, let's go ahead. So we got 3 people here. We got Karina. ideas on this one?
I'm happy to do it.
I'm still working on it, I don't know.
She's still working, okay, work on it for a couple minutes, yeah. It's good. You two back can work on it. And everybody else can.
I didn't do all of it, but I did a couple of stuff, I don't think
A lot of, that looks like Pythagorean identity stuff going on in there.
Wait, oh, okay. Right.
Oh,
Yeah.
okay.
Here, I'll get that now.
I think I figured it out. Mine, where it is.
Yeah, 'cause look, square data equals
Yeah, one.
1 plus 10 equals 6.
So, one plus one, result plus two squared u over.
Okay, so if you look at your Pythagorean identities, there's a Pythagorean identity, which is it's sine squared theta plus cosine squared theta equals 1. But if you look at the next Pythagorean identity, 1 plus tan squared theta equals secant squared theta. So literally the entire numerator is secant theta, secant squared theta. And like, correct me if I'm wrong, Mr. G, but that's.
Okay, Elizabeth, so Elizabeth articulated a solution to it. And a lot of times with these things, there's more than one possible way to solve it too. What do you think? Oh, yeah, sure. No, that's gonna be right. So you replace,
This equals this.
secant squared theta.
No, just show you.
Okay, I'm gonna show my way, because I want to talk way. So I looked at Karina, she really did a good job of this. What I would do, here's how I would handle it. I would say this is your first Pythagorean identity, that's equal to 1. So you replace these first two with 1. And what you have here is you got secant u here. And so do you see the replacement here? How this became 1? Okay? And now you have 1 plus tangent squared u. And so what is that going to be equal to? It's going to be equal to secant squared u over secant u. And what's that going to simplify to? Secant u. And if you wanted to leave this in terms, purely in terms of sine and cosine, you could write that as 1 over cosine u, right?
Is it still considered simplified?
Yeah, this one right here, since it's a non-reciprocal one, I would stick with that probably, that's your simplified version. So really that's it. What I want to do with the rest of the class period is I want to hand out your study guide. You can start looking at those problems, all right?